Mason. I'm the public relations head in Neuro, and together with the Committee on Undergraduate Enrichment, we're so excited to have Dr. Peggy Mason here with us today. Dr. Peggy Mason is a professor of neurobiology here at the University of Chicago, and she's helped us out with many of our events since our inception, especially our yearly brain dissection event that we do with a couple of the local high schools in the area. Dr. Peggy Mason, she studies the neurobiology of empathy and prosocial behavior in a rodent model. One of her most recent findings is that a rat who frees another trapped rat experiences ending that trapped rat distress as internally rewarding, and so they'll continue to free it again and again because they want to experience that feeling again. And without further ado, I would like to present Dr. Mason.
Thanks. Thanks for coming out at a fairly late hour. I'm a little older than you. This is about my bedtime right now. But so when I got into this, through a sort of a circuitous route. My research for 30 years, close to 30 years, was on how morphine produces analgesia. And because I was studying analgesia, I actually was in the broader field that I participated in was pain research. And I always thought that one of the most interesting things in pain research was the idea that watching another person in pain activates the same parts of the brain as being in pain yourself. That's really remarkable. You don't need a stimulus. You can get the same areas in the brain lighting up just watching another person be poked with a needle or have their hand crushed or whatever. And so I always followed that. And then in 2006, Jeff Mogul at McGill University made a discovery that was published in Science. And the discovery was that if one mouse was injected with if a noxious stimulus was administered to a mouse who was next to another mouse who was showing pain behavior, that mouse would show more pain behavior than if the mouse was next to a mouse that was not showing pain behavior. So in other words, he was contaging, he was catching the other guy's pain. He's saying, oh, you're in pain, well, I'm in more pain. So it was a really cool study. They called it empathy, and Science called me up for a comment, and I gave a comment that was really exciting. It showed that there's emotional contagion, that one mouse can catch the affect or emotion of another mouse. And so that comment got published in Science, and then Scientific American called me up to ask me to put a little blurb in Scientific American. So I did, and then they liked it. So it was on a blog. I don't really do blogs, but okay, I did a blog. And then they liked it, so they printed it, and then I never thought anything else about it. And then about 2 years later, 2 years later, I got an email from a graduate student, Inbal Ben-Ami Bartal, who was a graduate student with Jean Decidi in psychology. And Inbal was interested, well, Jean is interested in empathy, but he studies humans. He studies fMRI in humans and psychophysics and stuff like that. And Inbal had gone to his lab, and thinking she really wanted to work with humans, but then she came around to the fact that she missed the rats. And she wanted to get back to rats, and she actually, not just that she missed the rats, but she wanted to understand the biological basis of empathy. And to do that, she wanted to skip the humans, which were very, layered with culture and all sorts of cognitive layers that are arguably more or less biological, but she wanted to get right to the biology, so she wanted to try and see if she could find empathy in rats. So they came to me as the person who knew about rats. So I mean, basically I got really lucky. And I think a lot of science is serendipity. So this was her idea. I was in the right place. It's been an amazing ride. I have since then basically switched my entire lab to look at empathy. So Inbal's original idea was sketchy. It wasn't going to work. But I said to her, it's not going to work, but go ahead. Go downstairs. I got some rats. Go try it, and we'll see what happens. So she goes downstairs, and it was a complicated idea that she had about one rat figuring out that the other rat was hungry and then feeding it some food. This is basically a chimp kind of design. Okay, well, rats are not chimps. They're clever and they're sweet and they're nice, but they're not chimps. And so I didn't think that the rat was going to know that the other rat was hungry. But just to get it so that one rat had access to food and the other rat didn't have access to food, Inbal put one of the rats into a restrainer. And bingo, the rat on the outside goes crazy. It goes and attacks the restrainer, digs at it, jumps on it, just goes berserk, trying to figure out what the heck. So we said, okay, let's ditch this food stuff. That ain't going to work, but we're going to go for this restrainer thing. So we then spent, I don't know, more time than I'd like to admit, some months, better part of a year, in fact, designing a task that would enable us to see that the rat not only felt something for the other rat, so he clearly felt, we thought, well, it was clear to us that he felt something, but we had to show something. We had to enable the rat to do something about it. And Jeff's work shows that one rat can feel like another rat. One rat can detect the feelings of another rat, and that will influence how that mouse feels. And we wanted to be able to go one step further. You take that empathy and you do something with it. And what we wanted to try and enable the rat to do is to help the other rat. So what we did was we designed a task. So this is an arena. It's about yay big, like this. And in the center is this restrainer. And this is a commercially bought restrainer. The thing that took us a long time was designing this door. The door is a fancy door. And it's fancy because the door has to be hard enough that if the rat just brushes by the door, he doesn't open the door. But easy enough that the rat doesn't say, this is way too hard for me. I give up. I'm just a rat. So that's a delicate balance. And even so, we've had to work very hard to keep the rat in the game because this is difficult. Even if, I mean, we actually think that this is one of the most attractive reasons to go to the restrainer, is to help a trapped rat. But even if you don't buy our story, if we bait this restrainer with chocolate, it still takes the rat days to figure out how to open that restrainer. We're talking 3, 4, 5, 6 days. So it's not easy in rat cognition land to open this door. Okay, so the setup is that there's an arena. So here's a free rat, here's a trapped rat, here's this double pane door that can only be opened from the outside. So the trapped rat can't open it, the free rat can. We put these two rats in there for an hour a day, and we repeat that for 12 days. There's no food, there's no way, we can't give the rat instructions, there's no external reward. Now, there are a few aspects of this that I think are worth noting. One is that you can see from the previous picture, actually you can really see from this picture, the rat's not really squished. Okay, the rat can actually turn around in the restrainer. So this is, the rat would prefer not to be in the restrainer, we know that. If we turn the door around, he lets himself out, bingo, like that, all of them do. So they don't want to be there, but they're not freaked out. And I actually think that's one of the reasons this paradigm works. Because if it was overly freaked out, I think everyone would freak out and everyone would freeze. As it is, what we have to do is, what we found out when we did this just straight up, after 2 or 3 days, the rat gave up. It was too hard. And so what we ended up doing, and this is something called learned helplessness. This is something that rodents and other animals go through, humans. This is actually used as a model for human depression. So learned helplessness means I can't do it. It's too hard. I'm not up to it. I'm going to give up. I'm going to go into the corner and sulk. And the rats will do that. So what we did was after 40 minutes, so 2/3 of the way through the session, we opened the door 45 degrees. And at that point, either the trapped rat or the free rat can get out. All right? So, and one or the other one does. We don't count that as a door opening. But what it does is it gives these guys hope that they can rise to the challenge the next day. Okay? So they play our game. Okay. So what happens? Well, here's what happens. This is our initial study. And what you can see in the blue is the percentage of rats as you go across the testing days, the percentage of rats that actually open the door, the free rats that open the door to release the trapped rat, and the latency that they do it at. So they do it, and more of them do it, and they do it at a shorter and shorter latency. By day 12, they're going in there. They check out that it's the same gig as yesterday. They go, they open it within a couple minutes. Okay, so that's, and they don't do this for an empty restrainer. So it's not because, this is what I call the Mount Everest explanation. It's not because the restrainer is there. That is not particularly attractive to them. They're not going to open it. And they don't do it for a toy rat containing restrainer, which is not a particularly surprising result given the empty restrainer. Okay? You guys should ask me questions if something's not clear. Okay, so what I want to do is go through the steps that we think the rat has to go through. We think that, yeah?
Is the restrained rat the same rat every time?
Yeah, in this study, it's always the cage mate.
Okay.
Doesn't matter. I can tell you that now. Okay, so the first thing that has to happen is that the rat can't look at the door and say, oh, I see that they've put this counterweight on that side, so I'm going to push it from the other side. He's not an engineer. So what the rat has to do is get to the restrainer and be there enough time that somehow accidentally he's going to open the restrainer. And I do say he because we actually use male rats for the most part. So the first thing is an opportunity to accidentally open the door. Well, once he opens the door, oh, that felt good. I let this guy out. That was good. Yes. And so he experiences what we believe an internal reward. And I will show you what I think is our evidence for that. And finally, there's a motor piece to it. Now that I did this accidentally and I liked it, I'm going to do it again, and I got to cut to the chase and figure out how to do it intentionally, how to do it easily. And we actually are very, we're certain that the rats know exactly what they're doing. By day 12, when they're opening the door, they know exactly what they're doing. Okay, so let's go through each of these. So the first one is how do they accidentally open the door? Well, to accidentally open the door, the rat has to leave the sides of the arena. And if you know rodents, they like to stay in the corners and the sides. They do not like to go in the center. That's where you get eaten. And so most rats will just circle around like this. They won't go into the center. They have to have a good reason to go in the center. And we knew that this was going to work because immediately the rats go into the center to investigate the restrainer. All right? So the next just shows you a movie. This is a toy rat from IKEA. This is an empty restrainer. And this is a trap cage mate. And it's sped up, so it goes really fast, but you'll see that the guy with the trap cage mate I think you'll see. Yeah, okay. Spends more time at the restrainer. So he's on top of it. These guys are off in the corner being depressed. So yeah. So he has lots of opportunity to be near the restrainer and accidentally open that door. Okay. So, and when we can quantify that, how much time do they spend in the center versus the edges? And they spend a lot, only in the condition where there's a trapped rat do they spend a lot of time in the center. Okay, so the next thing is that when they accidentally open the door, that's got to be rewarding. Now I have a friend who is a neuroscientist, and he's actually part of the National Academy. He's a very smart man, very good neuroscientist. And he told me, and I've never forgotten it, that he got into neuroscience because he wanted to understand why do anything. Why move? Why move? What motivates you to move? You've got to have a motivation. And that's what that's what motivated him to get into neuroscience. From my point of view, what motivates the rat to go do this? You just sit there. Why bother? And so that's the next thing I want to show you. So when we started to do this, we very quickly realized that the free rat had a big reaction when the trapped rat got out. And what we did was we aligned everything to the time of door opening, and what we just did was calculate his velocity, the free rat's velocity. How fast was he moving? And what you see is that he speeds up just before he opens it, but then the velocity stays elevated for a good 10-15 minutes afterwards. Now, I'm going to show you this in a minute. This looks like a celebration. What happens is the trapped rat gets out, and he hasn't been in this arena, so now he's going to go around the edges of the arena to explore it, and the free rat's very excited. I just did this, I just did this. And he jumps on the trapped rat, on the released rat, and he licks him, and there's a lot of fervor about his activity. Yeah?
Is there any way to be sure that the internal reward comes from freeing the rat per se versus like, wow, I made something happen in the world? So for instance, the other two groups of rats didn't accidentally.
Right. So here's a situation. Let me come back to that, and this gets at it. In the next slide, I can nail that home. Okay. So what this is this is just a group. It's a more recent experiment where we tested 8 animals. 5 of them became openers, and 3 of them not so much. And each day is one of these columns, and on each day, if they opened, it's a filled square if they opened on that day and on the subsequent day. It's an open square if they opened on that day, but they didn't open on the subsequent day. So you can see that these openers, once they open again, and then they open again, and then they open again. And they don't take time off, actually, these guys. And then they open on the last day. Of course, we don't know that they would open on the next day, but probably would in this case. Whereas these guys, they open, but they don't, it's not sufficiently meaningful to them that they go and bother to open on the next day. And if you look at, this is a group of 70 rats in a study that we just finished. And so for the openers, virtually every opening, and by the end, every opening is followed the next day by another opening. And you can think of these sequential openings as actually rewarded openings. Openings that feel good. that make that rat want that again. I mean, I would argue that this is a craving. Just like a person has a craving for a drug, these rats have a craving to help the trapped rat. The non-openers, they accidentally open it, but it doesn't motivate them to do it on the next day. And the answer to your question is that for the if it's an empty restrainer, if there's not a trapped rat, or if it's a toy rat in the restrainer, this is all you get. You never get this sequential build that is evidence for a craving. Yeah.
How many rats did you test for?
Well, there's a lot of studies, and this is 70.
70. Okay, so the non-openers, were they rats that had a live rat but chose not to open, or were they?
This is a different study. So these rats, we understand why they didn't open, but I don't think we're going to get there in 40 minutes.
Sociopaths?
What's that?
Sociopaths.
Not sociopaths. So in general, if you just tested everybody with a cage mate, about 25% of them don't open at all. They don't open. Well, I mean, they open once or twice. Maybe they get there towards the end, but in general, they don't open. And we call them non-openers. So those non-openers, 90% of them, and we have evidence of this for this, 90% of them are just too nervous. They're just freaked out. They're just freaked out by the other guy's distress. And that fits with the human literature. The human literature would suggest that you catch another individual's distress. The next thing you have to do is to down-regulate that distress. Remember that that person is different from you, that you're not caught up in the problem, they are, so that you can act to help them. In rat terms, if they don't realize that they're a separate individual from the one that's trapped, they're going to freeze. Rats freeze when they're scared. So the fact that they don't freeze is a tribute to their ability to downregulate. But every once in a while, these rats can't do it. And so about a quarter of them don't open. Now, there is a debate in the lab as to whether there are psychopathic rats. And I will tell you that there have been maybe 2 or 3 rats that most of us think are psychopathic rats. So they didn't not open because they were nervous. They didn't open because they didn't like other rats. Yeah.
Could the mice communicate at all? So like, I saw that there were.
The rats can communicate all they like.
So was it possible that the one in the trap was pressuring the other one to? I'm locked in here. Open the door.
Absolutely. I mean, what's the alternative? Is the alternative that the free rat reads the mind of the trapped rat?
But if he was locked in one day and then he was locked in the next day and he was locked in the next day, then you just open it because, hey, dude, I'm locked in here. Open the door for me again. Open it again. Open it again.
Well, there's no question that as for humans, rats are going to respond to distress. If the rat was happy in the restrainer, they're not going to open the door. And in fact, we know that we gave rats, the trapped rat, Valium. He doesn't open the door. The rat there has to be a reason to open the door. You have to help somebody because they're in distress. You don't help somebody that's perfectly peachy keen. So yeah. So the rat has to communicate, has to have an affective communication from the trapped rat. I am in distress, and what we know, which I'll show you in a minute, is that the free rat actually has to catch that distress, has to feel at least a portion of that distress. So yes, they do communicate. We don't know the modality of the communication. Yeah, Angela.
Is there a difference in the reaction, like their celebration reaction, when you guys open the door and when they open the door themselves? It's a good question. They don't appear to celebrate when we do it halfway and the trap guy gets out. I don't think there's a celebration. And as you'll see, the celebration seems to decrease as the days go on.
It's the biggest the first time that they open. Yeah.
How did you know that increase in activity was correlated to celebration?
How did I what?
How did you know that increase in activity was correlated to celebration?
I actually can't hear you.
How did you know that the increase in activity was correlated was a celebratory behavior?
Oh, I don't know it's celebratory. I'm giving a talk, so I'm going to tell you it's celebration. I'm not going to put it in my paper because, you know, people are going to freak out over thinking that we are like rats. But it looks like a celebration. So could it be something else? I guess so. I doubt it. I don't know what else it could be, given all that we know about it. It's a positive experience. It makes them do it again. It's an aroused experience. They are aroused. They are active. So it's some positive aroused experience. Yeah.
Have you tried measuring brain activity and reward pathways to actually determine if it's a rewarding experience when you open the door?
We are working right now, trying to get into the brain. We've got some rats that are going into the magnet, so that's kind of fun. Yeah, we don't have that yet. Okay, so opening begets more opening because the simplest explanation for that is that it feels good to the free rat to open the door for the trap rat. And the final thing is how do you open the door? This is not trivial for a rat. It's just not. We kind of wish it was, but it's not. So what we figured out was that when the door first opens, the first time it opens, it falls over, it makes a big noise. And what do rats do when they hear something they don't expect? They freeze. And we noticed that indeed they froze. So they freeze for some 4 to 8 seconds for a few days, but by day 6, they're not freezing at all. They're not freezing at all. They know exactly what's going to happen. They know the result of their intentional act. They know that when they open the door, it's going to make a noise. They ignore the noise. And this is now, I'll just show you a video which is kind of fun about this. I think this started. Yeah, okay. So this is times 20. He has no clue how to open the door. So he's just sort of circling around the trap guy. And you can see the trap guy will move around. You can see he switches positions. He kind of follows the free guy. Okay, so this is the first opening, and what you'll see, you'll hear the door fall over, and you'll see both of the rats freeze. So now you'll see. You'll see in a minute that the release guy now is going to race around the arena, and the free rat chases him. That's what we call the celebration. Now this is the last day. You see, he just went in. He went in at 04 seconds. And in about 8 seconds, he's going to open the door. He kind of goes in, makes sure this is the same gig as yesterday. So he knows it's the same thing. So now he's going to open the door, and they completely ignore the sound. Okay, so he knows exactly what he's doing. And it's a muted celebration. So, yeah.
It's interesting how the rat that frees the other one wants to go inside and explore. Do you have any data surrounding that?
Yeah. So why do they go into the restrainer? It's a really good question. It has
the hell out of there.
Well, you would think, but my impression is that the open restrainer is not, it's a different beast. It's not a restrainer that you're locked in. But, funny you should say that. So an undergraduate in my lab, Michelle Yoon, noticed this, or she started to make some observation about this 2 summers ago, and she's now doing a project. We ordered the rats actually today for her to do a project to try and figure out what is the meaning of the open restrainer, and is it distinct, or does it retain meaning from when it was closed? And so, you know, we'll know in about a month and a half. Okay. So, yeah.
What conditions, like, so you put them in the box for 1 hour a day, right? For the other 23 hours, what would the rats do?
Oh, they live in a fairly boring, unenriched environment in the animal facilities.
Okay, so it's just like 23 hours they're in a cage, and then for 1 hour a day you take them out and put them in the restrainer.
Well, they kind of hang out in the room for a little while.
Okay.
So, did you have a question? Yeah.
Prior to the experiment, would the rats have like previous experience with each other or contact, or they?
Well, these are cage mates.
Okay, so they're.
These are cage mates. It does, but it doesn't matter.
So it would also work for like a stranger rat.
Yeah. Okay, so this is all great, and it does suggest that that having a trapped rat there is required to elicit door opening. But the simplest explanation at this point is that they just want to play with the guy. Rats are very social, so I'm alone in here. I'm alone out here in this arena. I want to get you out so I can play with you. So we worried about that, and we set up an experiment, which was our, what we call the separated paradigm. So it's 2 arenas put together. The restrainer is, instead of being in the center of the arena, it's up against the divide between the 2 arenas. When the free rat opens this door, the trapped rat exits into a separate arena, and the 2 rats can't play. So the question is, will he still open? This was really tough. The way the rat likes to open the door is to put his nose underneath this pane and lift it up with his snout, and so now he can't do that. He has to pull it from the side. So now what was a difficult task has become basically impossible for a spray gully rat. So we were unable to teach this. They just never got it. If we started with this paradigm, they never got it. So what we ended up doing was training them on the regular paradigm so they understood how to open the door, and then giving them this paradigm, which is a tougher one, and they could still figure out how to open the door. So what we did was we took 2 groups, and we did, in this situation, this is the regular paradigm here, and this is the latency to door opening. So they're opening the door, and now we put them in this separated thing, but with the restrainers empty. And you can see that they eventually extinguish opening. They stop opening. And if you put back in a cage mate, they start opening again. If you do it the other direction, from the trapped direction, they continue to open for a separated cage mate, and then they've done it for a long time, so it actually takes them quite a while to extinguish, but they eventually extinguish when they're put in there with an empty restrainer. So what this tells us is that playing with the other rat is not required. Okay? So not required to motivate helping. So at this point, sort of people were starting to be convinced, but we could tell that people weren't all the way convinced. What I wanted at this point was an in-your-face experiment. And so what we decided to do, we had some other experiments going that were looking at feeding, and we had some rats that could really chow down on chocolate. So these rats, if you gave them a bowl of chocolate chips, they would eat on average more than 7 chocolate chips. So what we did was we gave them 2 restrainers, one with their cage mate and one with chocolate chips. And we put in 5 chocolate chips. And they were allowed to do, this is not Sophie's choice, so they were allowed to do any of the 3 options. They could only open for the cage mate, they could only open for the chocolate, or they could open for both. And what they ended up doing was they opened for both at not different latencies. So on one day they would open first for the chocolate, and on another day they would open first for the cage mate. The most surprising result in the entire study, this first study, was that not only did they do that, well, that actually didn't really surprise me, but what surprised me was they shared the chocolate. Didn't eat all the chocolate, even though they're eating on average 7 a day, and this is only 5. And there's so many ways that the free rat can hog the chocolate and still free the other guy, but he doesn't. On average, this guy gets 1.5 chocolates. That's a lot of counting. We reproduced this study, so that's 5 chocolate chips. We did this for a TV station that then decided to drop this segment. So annoying. This is a recreation. So this guy is going to come over and he's going to open first for this guy, and then he'll open for the chocolate. There he goes. And now he's going to chow down.
So that was freed doesn't know how to open the restraint?
In general, no.
Okay.
Yeah, he'd probably do it by mistake, if ever. Okay. So what that tells us is that freeing a trapped cage mate is on a par with a highly palatable food like chocolate. That's pretty good. I'm good with that. So the next question that one of the questions that we're working on right now is, what exactly is the motivation? Does the rat actually have to be distressed? And so what we did was we started giving these rats benzodiazepine midazolam. So this is like Valium. And we started by giving it to the trapped rat. And we found that the trapped rat getting either a high or a low dose of midazolam, the free rat doesn't open for the trapped rat. I mean, so think about it. These rats are not cognitive beasts. They're not advanced. They can't figure out. They cannot intuit. They cannot reason through, oh, that guy must be distressed because he's trapped in that restrainer. They don't get that unless the trapped guy shows distress. And if we give him Valium, he can't show the distress. So when the trapped rat gets midazolam, the free rat basically ignores him. It's like an empty restrainer. So the next thing was, does the free rat actually have to feel any distress himself? We think, in the human literature, the idea is that one individual feels distress and another one actually has to catch it in order to be motivated to help that distressed individual. So we wanted to see whether that was true. And basically as a control, we also did the same thing. We gave this rat midazolam or saline with instead of a cage mate in the restrainer, chocolate chips. And this is going to tell us whether this is just making him zonked out so he can't move. And so here are the results. If there's a cage mate, this is the proportion of rats that open. So if they're given midazolam, they don't open. They just don't open. Not for a cage mate. If they're given saline, they do open. If they're given midazolam and it's chocolate, they open beautifully. So what that tells you is that it's not like it's preventing them from learning. It's not like it's preventing them from moving. It's not preventing them from being motoric wizards. It's just preventing them from being motivated to help this guy. because they can't feel his distress. Yeah,
Wait, so which rat was given?
the free rat.
Okay, in both situations?
Yeah.
Okay.
Do you have any ideas of why they're not opening for chocolate when injected with saline?
Yeah, exactly. So they're not opening for chocolate when they're injected with saline. And they're opening for rats when injected with saline, but at a lower proportion than normal. Why? Do you have any ideas?
Does getting injected freak them out?
Getting injected is extremely stressful, and stress is the enemy here. So if they're stressed out, they can't act. And so it's fewer of them can get over that added distress. That's exactly right. The other implication of this is that they get over that added distress to free the cage mate, but not to get the chocolate. So it kind of suggests that freeing the cage mate is just maybe a little bit more valuable than accessing the chocolate.
I'm trying to phrase this as earnest sounding as possible, but could the Valium just give them the munchies?
Could the what? Midazolam. Oh, we tested how many chocolates they eat with midazolam.
Okay.
And I don't think it significantly changed.
Okay.
Yeah. Yeah.
So you think that when they see distress in the rat, they feel the empathy of the distress. They empathize with the distress, and then
They feel a bit of the distress.
right. So then, have you ever tried putting the trapped rat as the free rat after?
Exactly. So that's an experiment that's high on the list. The prediction is if the rat has been trapped before himself, then he should be even more motivated, because now he's sort of cognitively motivated as well as affectively motivated, and we just haven't done it. Yeah.
What's the memory length? I mean, how soon after being trapped would you have them be the one to the free rats before they forget the experience of being in the box in the restrainer?
I have no idea. I mean, we'd have to test it, but we'd probably just do it the next day. I can say that the memory for doing this task, they can take 2 weeks off and they'll go in and open the door. This appears to be a memory for life. Yeah.
Have you tried giving them like a motivation not to open the door, like a shock when they open the door?
So in experiments that I just don't have, I mean, I'm already over, so I don't have time to talk about. They won't open for certain rats. And we can predict which rats they're not going to open for. We can arrange the situation so they won't open for a rat. So it is a selective behavior. They're deciding to open. I'll open for you, but I will not open for you. Yeah.
Well, the part that I took from that was, is there a case where they would overcome some, like, even if it were electrified, they would do it because they're so strongly motivated?
Yeah, I've thought about doing this, and the way I've thought about doing it is, well, okay, so we did a very crude pilot on this, and it was about 3 pairs of rats, and all of them acted the same. So what we did was we put the restrainer here, then we made this corridor, and then we put the free rat on the other side of the corridor. And the corridor was taken up by a pool that had, at the beginning, it had oil that was spiced with cayenne and all sorts of stuff that rats don't like. Well, even if it's just oil, vegetable oil, they won't touch it. It's not worth walking through oil to free the guy. So I can tell you that. Then we switched out the oil, we put it in water. Boom. So it's worth walking through water, which they're not that excited about, but it is not worth walking through oil. So how to do this in a better way, I have these floors that I can dial up to any degree I want. That's the real way to do it. We just haven't, that experiment hasn't risen to the top of the list yet. So it hasn't been done. Okay, so what does this mean? What I think it means is that if the rats do it, they're answering to biology. That's all they got going. So they see an individual in distress, and they have some biological instinct to help that individual in distress. I think that if that is our biological inclination and our biological inheritance as mammals, I would submit that not helping means you're actively suppressing that inclination. You're actively suppressing that motivation. I think it takes energy to not help somebody in distress. And why do we have this? This is actually just, this is basically an excuse to show a really cool picture of a painted turtle giving birth to eggs in my backyard. So the whole thing caught on video for hours. But she is never going to meet her babies. Never going to meet them. And there's no real. She's got no. I don't think if she ever met them, if she ever happened into them, she wouldn't recognize them and she wouldn't care about them. Just another turtle. On the other hand, I can tell you that rats are amazing mothers, like other mammals. So why would we evolve any inclination to help? Well, because mom has to help the babies. Mammalian babies are completely helpless. If mom doesn't know when these babies are cold or hungry or in danger of predation, those babies are dead. And mom's reproductive success is 0. So she has to know what's going on with these babies. And the thought is that, in fact, the same affective circuits that support her knowing how her pups feel and being able to adaptively react to how her pups feel has evolved to be present not only in moms, but in other females, and not only for the pups, but for unrelated others, and not only in females, but in males. And why would that be? Because this is not the only situation where cooperation and helping another individual is advantageous. As adults, animals live in social groups. If the social groups get along well, then they have a safe domain where they can live. They are better at avoiding predation, and they are better at finding food together. So there are a lot of reasons to cooperate and a lot of reasons to support positive social behavior. And I think that helping, motivated by empathy, is the building block for positive social cohesion. I just want to end by saying, a ton of this was done by undergraduates. Virtually, this is Imbal. She's now a postdoc. This is a medical student. But the rest of these people, there are 2 high schoolers, and the rest of these people are undergraduates. They work in the lab. They make great contributions. We have a lot of fun. And the final thing I want to say to you, as neuro people, it is never too early to start your study of the nervous system. So I commend you for starting now. Okay, thank you.
Thank you so much for having a great talk. So we'll now do a question and answer session of about 5 minutes. We have dinner waiting outside, but then if you guys want to ask Dr. Mason questions more informally during the dinner, you'll be here for a while. But you could moderate.
So I encountered a very strange case where there was a female monkey, I don't remember, but she had just had
offspring, and then her daughter had just had an offspring, and it was a food shortage situation. So they both start eating the younger offspring. Like she decided that her daughter's survival and the survival of her like grand offspring meant more than the life of her offspring. I just wondering, do you think that's
I mean they do eat their babies. If things aren't going well, there's a lot of protein there. There's a lot of substance there. So they're going to eat the babies.
It seemed like a very like conscious decision of like my grown daughter who's already shown like.
Yeah, it does seem, okay, so it does seem like a calculated decision.
That's what I'm, yeah.
It seems like a calculated decision. I would caution you that what drives us are proximal motivations, not ultimate calculations. And so it seems that way, but it's unlikely that that's what's driving you. Sure.
Have you tried the same experiments with female rats?
Yeah, the female rats are very good. The way I put it is the female rats are slightly better on a variety of measures. If the floor is having no empathy and the females are here, the males are here. So I think the bigger message is that males and females both show it. Females are slightly better. Yeah?
Have you done males and females?
No, that would be breeding. Not empathy.
Something like if you opened it a little for them and they got out, like the free rat didn't really seem excited at all?
Well, we know that the free rat is quite pleased with himself. And the reason we know that is because on the first day that he encounters this, he has a court response. Okay? That means rats have corticosterone, which is their version of cortisol, which is a stress hormone. So when you freak out, you release a lot of this hormone. So on the first day, a free rat has a big release of corticosterone. On the last day, if he's become an opener, he has no release. Whereas the non-openers continue to release corticosterone. Curiously enough, the control condition, they still release corticosterone. There's no task. They're not opening, and there's no trapped rat. But the situation is sufficiently stressful that they still release corticosterone. But if they open, they release none, 0. So that tells you that is the mastery of the task is protective against any freak out at all.
But like if the rat is freed and they're not the one who freed it, like it doesn't like please them at all to see the other rat free, or does it still?
Oh, we don't know how the rat feels about that. In some situations where the rat is deliberately not becoming an opener, they'll fight. But we don't. I don't know. I don't know. Yeah.
I know it wasn't really what you were trying to test, but if you tested and you found, you found the levels of cortisol or cortisone, corticosterone. Yeah. Well,
Court.
Okay, so then in like the 2 or 3 rats that you thought were like psychopathic.
Well, we didn't have it. That was a particular study. There were no psychopaths in that study. Okay. Yeah. We had one psychopathic rat that had 5 standard deviations more fights than any other rat. Wow. 5 standard deviations. We kind of had to toss him out of that analysis. Yeah.
Do you think they would free an animal of a different species, like a mouse?
I get a lot of stuff from people around the world, essentially. And I got this incredible video from this kid in Texas, a high school student, who had basically built his own little situation. Very similar, but low cost. And he had a rat. So he shared the same thing. He basically confirmed our thing. And then the second one was with a mouse, and that was just as worried about the mouse as the rat. And then the third one was for a lizard. And goes over, sees the lizard, and runs the other way. Yeah.
showing empathy. That might affect.
We absolutely think there are degrees. And so, like, this past summer, we can take away their ability to open for somebody. How can I put this? We can introduce a rat to another rat that he would not normally open for. And if we give them a certain social situation, he will now open for that rat. If that rat then gets bullied, not even by the rat that he's helping, but just is bullied, period, it decreases his motivation to help anybody, and it decreases it more for those that are the ones that we've just taught them. For the cage mate, that persists the most through the bullying. So we do think that you have to reach a threshold to help, but there are some animals that are just above the threshold, and there are some animals that are way above the threshold. And there are some situations that enable them to be here or there.
All right, guys.
Okay.
Let's bring the rest of the questions outside. Dr. Mason's going to be having dinner with us, so feel free to just, come up and ask any questions you have.